So this is grade 12, paper 2, question paper. So we'll be starting with question 1. So without wasting any time, let's jump straight into it. So we'll start with question 1.1, and question 1.1 has its own set of questions. So we are told that Uncle James bought a house and decided to do some renovations to the lounge area. He plans to change one of the walls in the rooms. So we're going to start with question 1, and we are told that below is the wall he plans to change, and then we are given the shape of the wall, and it has the length and the height. Okay, so we are given both the length and the height, and then we are told to use the information above to answer the questions that follows. So the first question is going to be question 1.1.1. So question 1.1.1 says that define the term perimeter. So in short, perimeter is the total distance around the shape. So it's the total distance around the entire shape. So it's the total distance around the entire shape. Around the entire shape. Okay, so now let's move to the next question, which is question 1.1.2. 1.1.2. So question 1.1.2 says that convert the length of the wall to meters. So if we look at the length on our diagram, we can see that the length is given in centimeters. So the length is 370 centimeters. So we need to convert it into meters. And we do know that if we are converting from centimeter to meters, we need to divide by 100. So converting from centimeter to meters, we need to divide by 100. And again, we don't just leave it here. We also need to understand that if we are converting from meter to centimeter, we then need to multiply by 100. So converting from meters to centimeters, we need to multiply by 100. So vice versa. Okay, so in this case, we are converting from centimeter to meters, meaning that we are going to divide by 100, meaning that our length is going to be 370 divided by 100, and our answer will be in meters. We can just remove the centimeter. So our answer, the answer that we are going to get, is going to be in meters. So now we are going to plug that into our calculator. So it will be 370 divided by 100, and our answer will be 3.7 meters. 3.7 meters. So this is our length. Okay, so now let's move to the next question, which is question 1.1.3. So question 1.1.3 says that calculate the perimeter of the wall. You may use the following formula. So remember guys that the perimeter is the total distance around the shape. So if we check, we can see that our shape has 4 sides. So our shape has 2 length and 2 heights. So to get the perimeter, we need to calculate we need to add up all the sides. So the formula that we are given says that P is equals to length plus length plus height plus height, meaning that our P is going to be equals to, so we know that our length is 3.7, the one that we just calculated. So our length is equals to 3.7, meaning that we are going to say 3.7 plus 3.7 plus our height, which is 2.1. So our height was given in meters, so we didn't have to convert it back to meters because it was already in meters, meaning that we are going to take it as it is. So it is going to be plus 2.1 plus 2.1, and that will be our perimeter. So now we're just going to plug that into our calculator. So it will be 3.7 plus 3.7 plus 2.1 plus 2.1, and our answer will be 11.6 meters. And that's our perimeter. Okay, so now we'll be moving to question 1.2. So before we do that, we need to create a bit of space on our board. And don't forget that we do have extra classes, guys, and we also do have study guides. So if you need a study guide, you can just text the number on the screen on WhatsApp, and then you will get everything that you need. Even extra classes, our extra classes are very cheap. It's only 80 rands per month. So you pay once in a month and you attend twice a week and 8 times in a month if a month has 4 weeks. Okay, so now let's move to our next set of questions, which is question 1.2. So now let's move to question 1.2. So we are told that Jameson will win a club cycling trophy if he is able to log at least 600 kilometers of cycling distance in a 7-month period. He cycles as follows. So the first one was the Vineyard race in February, where he completed 75 miles. And the second one was the Ocean to Ocean race in March, where you completed 114.3 kilometers. And the third one was the Karoo Fun race in April, where you completed 271 kilometers. And the Charity Fun sprint, he completed 148.1 kilometers and was his last participation in June. And we are also told that 1 kilometer is equals to 0.6214 miles. Okay, so now let's go ahead and work on the provided questions. So we'll start with question 1.2.1. So question 1.2.1 says that calculate in kilometers the distance he cycled in the vineyard race. So if we look at the vineyard race, we can see that the distance was given in miles. So we need to convert it back into kilometers. Okay, and we know that 1 kilometer is equals to 0.6214 miles, meaning that to convert 75 miles into kilometers, we just come and say 75 divided by 0.6214, and our answer will then be in kilometers. So let's go ahead and work that out. So we are going to say 75 divided by 0.6214, and our answer will be 120.69. Be 120.695 kilometers. And if we want to convert this into one decimal place, it will be 120.7 kilometers, because our 9 is greater than or equals to 5. So our 9 is greater than 5. That's why our 6 then became 7. So that's the answer for question 1.2. And now let's move to the next question, which is question 1.2.2. 1.2.2. So question 1.2.2 says that, hence, determine the total distance logged by Jamieson throughout the period. Give your answer in kilometers. So now we need to calculate all the total distance that Jamieson logged. Okay, and the answer needs to be in kilometers. So what we are going to do, we are going to add the total distance logged. Total distance. So we are going to start with the first one, which is the vineyard race in February. So he completed 75 miles, and we know that 75 miles in terms of kilometers, it will be 120.7 kilometers, because that's what we calculated on question 1.2.1. And then secondly, we are going to add the ocean to ocean race that he completed in March, and the total distance was 114.3 kilometers. And then now we are going to add the Karoo Fund race that he completed in April, which was 271 kilometers. And lastly, we are going to add the Charity Fund sprint, which he completed in June. So it was his last participation in June. So the answer will be 148.1 kilometers. So this is the total distance he covered. So now we are just going to add everything and find out how much the total distance were. So we are going to say 120.7 plus 114.3 plus 271 plus 148.1, and our answer will be 654.1 kilometers. So this is the total distance that he covered. Okay, so that's our final answer, and we have given it in kilometers as the question has said. Okay, so now let's go to our last question for question 1. So next we have question 1.3. Question 1.3. So question 1.3 says that the road map of the MediHelp Stellenbosch Cycle Tour is shown in Annexure A. So I will also include annexure A on the right hand side so that you can see and also be able to follow how these questions are supposed to be answered. So we are told to use annexure A to answer the questions that follows. So we have a set of questions as well that we are going to use annexure A to answer. Okay, so we are going to start with the first one, which is question 1.3.1. So question 1.3.1 says that name one town that is situated directly on the road. So if we look at our road, we can see that there's only one town that is situated on the road, and that town is called Peniel. So this is the only town situated on the road. So that will be our answer. So now let's move to the second question, which is question 1.3.2. 1.3.2. So question 1.3.2 says that how many water points are available on the Medihalb-Stellenbosch cycle? So if we look on our map on the right hand side, at the bottom, we can see that we are given the water point symbol. So we are given the water point symbol. And if we count those symbols, we can see that in total there are 5. And those water symbols are located on the road. So you can see that they are pointing on the road. So our answer will be 5 water points. 5 water points. Okay, so now let's move to the next question, which is question 1.3.3. 1.3.3. So question 1.3.3 says that which national road crosses the road? So we all know that the national road is represented by N. So once you see N on the road, it means that the N stands for national. So in this case, you can see that the N1 passes through the route. So the answer will be N1. Okay, so now let's move to question 1.3.4. 1.3.4. So question 1.3.4 says that in which general direction is Stellenbosch from Peniel? So it's Stellenbosch from Peniel. Okay, so in our map we can see that here would be Peniel, and then here would be Stellenbosch. That's how. So if you look on the right hand side on the map, you can see that that's how those directions are. So now we need to find out which general direction would this be. So if we are here, maybe we can just use a different marker for it to be more understandable. So if we are here, so this will be our center. So we can just use our general direction map. Okay, so we know that up here will be north, and then down here would be south, and then here would be west, and here would be south. So if we are here, which the general direction is Stellenbosch. So we can see that Stellenbosch is between west and south, meaning that our answer is going to be south west. Okay, I hope that makes sense. So if it was somewhere here, it was going to be north. So it's east. It was going to be northeast. But our answer here is going to be southwest. Okay, so now let's move to our last question for question 1, which is question 1.3.5. 1.3.5. So question 1.3.5 says that identify the mountain pass situated on the route. So if we look on the route from the start, we can see that the route is given. So let's assume this is the route. So we can see that on the sides we have something like this. So this represents a mountain, and that mountain in this case is called the L-shaped pass. So that's our answer, and that brings us to the last question of question 1. Now we are going to start with question 2. And without wasting any time, let's get down to it. So we'll start with question 2.1. So in question 2.1, we are told that Mr. Salters traveled from East London to Johannesburg via Bloemfontein to deliver boxes of seed. The map below shows the national roads of South Africa, and we are told to use the map above. So it is the map on your right hand side to answer the questions that follows. So now let's get down to our questions. So the first question will be question 2.1.1. So question 2.1.1 says that identify the type of scale used on the map. So if you look at the far left above, you can see that there is a scale that is provided, and we can see that there is a straight line, and it also has some bars as well. So this scale is called the bar scale or the linear scale because of the straight line. So we can either say bar scale or linear scale. So now let's move to our next question, which is question 2.1.2. Question 2.1.2. So question 2.1.2 says that name only 2 national roads that Mr. Salters will travel on from East London to Johannesburg via Bloemfontein. So if you look at the map and we are in East London, we can see that from East London to Bloemfontein, Mr. Salters will be using the N6. So this N stands for national. That's why it's a national road. So it's N6 from East London to Bloemfontein. But just before getting to Bloemfontein, he then on-ramped. He then found an on-ramp and joined the N1. So you can see that before he reaches Bloemfontein, he then joined another road, which is the N1. And then if you check the N1, it takes him straight to Johannesburg, meaning that our answers will be N6 and N1. And N1 is also a national road because of this N that is here. And besides that, if we go back to our scenario, we are told that the map below shows the national roads of South Africa, meaning that each and every road that is shown on the map is a national road. Okay, so our answer for question 2.1.2 will be N6 and N1. Now let's move to our next question, which is question 2.1.3. 2.1.3. So question 2.1.3 says that Write down the general directions that a person will travel from Cape Town to Garris and from Garris to Abington. So we are going to start with Cape Town. Cape Town to Garris. So if we look on our map, we can see that here is Cape Town. So here is Cape Town. And then here is Garris. So if we draw our direction map, we can see that it will be something like so the center will be Cape Town, and then this will be our north, south, west, east. So we can see that the direction from Cape Town to Garris is found in the north. So our answer for Cape Town to Garris, our answer to the question of Cape Town to Garris, it will be north. The general direction will be north. I hope that makes sense, because we are moving here to here. And then if we are in Garris, maybe before we get to that, we can just start by writing that from Garris to Abington. So if you look at the map, you can see that from Garris to Abington. So maybe we can just add it underneath or on the side. So we can see that from Garris to Abington, so it comes this side. So this will be our Garris, and this will be our Abington. Abington. And if our Garris is the center, it means that our map direction will look like this. Will look like this. So this will be our north, this will be our south, this will be our west, and this will be our east. So if we are from Garris and we want to go to Abington, so it will be somewhere here. So it's in between north and east, meaning that our answer will be northeast. So Garris to Abington. Let's not write it here. So we can see Garris to Abington. Our answer will be north east. I hope that makes sense. So it's in between north and east. So now we are done with question 2.1.3, and let's move to question 2.1.4. So 2.1.4, we are told that Mr. Salter's wife wishes to visit Walvis Bay in Namibia during the December holidays. Mr. Salters comments that she would need a passport to go to Walvis Bay. Give a reason why his wife will need a passport to visit Walvis Bay. So the reason is that his wife will be entering another country, and you can't enter another country without a passport. So that's the reason. So the reason would be because his wife will be entering another country. That's why she will need a passport. Okay, so now let's move to our next set of questions. So now we'll be moving to question 2.1.5, but before we do that, let's first create space. Also guys, don't forget to subscribe to the channel so that when we upload, you can be able to see what we have uploaded and continue learning. Okay, so now let's move to question 2.1.5. Question 2.1.5. So we are told that the fuel tank of Mr. Salter's vehicle has a capacity of 75 liters. He claims that it will cost him 4% more if he fills his car inland instead of at the coast. So at the coast or coastal areas, so those are areas near the beach. Okay, they are called coastals. Okay, so he's saying that it will cost him 4% more if he fills his car inland instead of at the coastal. So to calculate the percentage of how much it will cost him more, we use the following formula. So we come and say inland minus coastal. So this is a percentage change formula. So we say inland minus coastal divide by coastal multiply by 100. So we multiply by 100 because we are looking for the percentage. So if we are calculating the percentage change, sometimes you'd find that this would be current, and then this will be previous. In some of the equations, you'd find that this would be our current, and this will be our previous, and this will be our previous. So here we wrote inland because we are told that if he fills inland instead of coastal. Okay, so that's the story, guys. And then you use this formula whenever you are told to calculate the percentage change. So here we just want to check how much it would cost him more, but still it is a percentage change. So now we can just go ahead and replace our values on our formula. So we'll come and say 22.49 minus 21.77 divided by 21.77 multiplied by 100. And now we are going to plug that on our calculator to see the actual percentage change. So we are going to say 22.49 minus 21.77 divided by 21.77 multiplied by 100, and our answer will be 3.37%. So it's in the percentage form because we multiplied by 100. Okay, so the question was that verify with necessary calculations whether his claim is valid or not. So we can see that his claim is invalid because it will cost him less than 4%. Invalid because it will cost him less than 4%. Okay, and then that's question 2.1.5. And then now we will be moving to question 2.2. We will be moving to question 2.2. So maybe we can just create space for that before we proceed so that we can just start on 2.2. And remember, guys, if I'm rubbing and you're still making some notes, you can just pause the video or you can just play it again. You can pause or rewind. I don't know what's the other word for rewind, but you can just rewind the video so that you can be able to get so that you can be able to understand before moving to the next questions. Okay, so now let's move to question 2.2. Question 2.2. So we are told that the Kruger National Park is a popular tourist destination. Some information about the park is given below. So we are told that the speed limit inside the park is 50 kilometers per hour on tarred road and 40 kilometers per hour on gravel roads. And then the gate times, the entrance gates open at 5:30 in the morning and the camp gates open at 4:30 in the morning, and all gates close at 6:30 in the evening. So we are told that Annexure B shows a part of a map of the Kruger National Park, and Table 2 shows the distances between camps and gates. Okay, so now let's go ahead and answer our first set of questions. So question 2.1.1 says that 2.2.1 says that give one possible reason why there are specific times for the opening and closing of gates at the park. Give one possible reason why there are specific times for the opening and closing of gates at the park. So one reason would be that wild is because, remember, at the park there are wild animals, so we can see wild animals would make it unsafe. Make it unsafe to be at the park. To be at the park if times are not regulated. If times are not regulated. Now let's move to our second question, which is question 2.2.2. So question 2.2.2 says that determine the difference in the number of main camps and other camps on the part of the map. So if you look at Annexure B for question 2.2, we can see that we are given a map, and then we are also given the key on the right hand side that shows the main camp. So the map, the key shows what the main camp is represented by on the map and what the other camps is represented by on the map. So we have main camps and we have other camps. So if you look at that symbol for main camps, you will see that there are 7 main camps on the map. So you just calculate. When you calculate, you'll see that there are 7 main camps, and then there are 5 other camps. So the question asked us to find the difference between the two. So the difference will be 7 minus 5. So this is the difference between the two. And we know that if we take 7 and minus 5, we will get 2, meaning that our answer will be 2. Straight to the point. Okay, so now let's move to question 2.2.3. Question 2.2.3. So question 2.2.3, it's 2.2.3. Okay, question 2.2.3, 2.2.3 says that if odd values, Skukuza at 5:15 and leaves the park through the Numbi gate, determine the time that he will reach the Numbi gate. And then we are told that the following formula may be used. So they are saying that the formula that we can use is so it's distance minus distance equals to, not minus, it's equals to, distance equals to speed multiplied by time multiplied by time. So he leaves the park through, so they're saying that if Odwa leaves Skukuza, so now we will be looking at table 2. We can see that there is a column for Skukuza. So they're saying that if Odwa leaves Skukuza at 5:15 and leave the park through the Numbi gate, so there is a column for Skukuza and there is a row for Numbi gate. So if we align them, we can see that Skukuza and Numbi gate, we have the distance would be 54. Remember, table 2 shows the distance in kilometers between some of the camps and gates in the Kruger National Park. So the distance would be 54. And if we go back to our scenario, we are told that the speed limit inside the park is 50 kilometers per hour. So the speed will be so the distance will be 54 kilometers and the speed would be 50 kilometers per hour multiplied by our time. Remember, we are looking for our time, so we don't know what time she will arrive at the gate. So that's what we are looking for. Okay, so now let's try see how we can solve this time issue. So we can see that we have 3 variables. So we have this distance, we have the distance, we have the speed, and we also have the time. Okay, so we can see that if we are given 2, so we have 2, but we have 1 that is unknown, the one that we are looking for. So now we need to make time the subject of the formula so that we can be able to calculate it using these two variables, which are distances and speed. So in most cases, you would find that we take this 50 to the other side. So we take it to the other side. Okay, and when you take it to the other side, time will be left alone, meaning that we can be able to calculate our time. But in this case, we have a multiplication sign between speed and time, meaning that we can't just take 50 to the other side. So the only way we can take 50 to the other side is by dividing by 50 kilometers per hour. So if we come here and divide by 50 kilometers per hour, this 50 and this 50, they will cancel, and we'll be left with time. But remember, what we do on the right hand side, we also need to do it on the left hand side, meaning that even this side will come and divide by 50 kilometers per hour. Okay, so this and this will cancel. That's why we are left with time. And then now we need to calculate 54 divided by 50. 54 divided by 50. So come and say 54 divided by 50, and we'll get 1.08. So our answer will be in hours. So meaning that it will take Odwa 1 hour, 1.08 hours time to get to the gate. But then we need to find the exact time that he got to the gate. So now we need to convert the 0.08 into minutes and seconds. So we know that we have 1 hour here already, so this is okay. We don't need to work it out. So we know that we have 1 hour, but we need to find the minutes and seconds as well. Okay, so how do we do that? So if we say 1.08 minus 1, we will be left with 0.08 hours. So we have taken out the 1 hour. So now we need to find out what 0.08 is, but in terms of minutes and seconds. So you need to pay so much attention to this question, because I've seen this type of questions so many times on so many different question papers. Okay, so if we say 1.08 minus 1, so we are taking away the 1 hour, we will be left with 0.08. So to convert this 0.08 hours to minutes and seconds, we multiply by 60, because we know that in an hour we have how many minutes? We have 60 minutes. That's why we are going to multiply by 60. So we are going to say 0.08 multiplied by 60. So if we say 0.08 multiplied by 60, we will get 4.8, meaning that it took her 1 hour, 4 minutes, 8 seconds. I hope that makes sense. So I hope it makes sense. So it took her 1 hour, 4 minutes and 8 seconds. So this is the minute and this is second. Okay, so it's 1 hour, 4 minutes and 8 seconds. So if we add that to 7:15, not 7:15, 5:15. So if now we come and say 17, 5:15, and we add 1 hour, 4 minutes and 4 seconds, it means that she has arrived at so it will be 19 past 6, and this is not 4, it's 8. 19 past 6 and 8 seconds. Okay, so that's our final answer for question 2.2.3. And now we'll be moving to our final answer for question 2, which is question 2.2.4. And if you have any questions, guys, you can leave some of the questions on the comment, and then I will come and clarify it for you so that you can understand. Oh, and we do have extra classes, so if you wish to join our extra classes, they are very affordable, only 80 rand per month, and you get to attend 2 times in a week and 8 times in a month. So you only pay the 80 rand once in a month. Okay, so now let's move to question 2.2.4. 2.2.4. So question 2.2.4 says that give a possible reason why most people visiting the park prefer to travel on the gravel roads instead of on the tarred road. So guys, you need to understand that if people are going to Kruger National Park, it means that they are going to see wild animals. So it is easier to come across wild animals when driving on gravel roads. on gravel roads. And that's our answer. Now we are done with question 2.2.4. And that brings us to the end of question 2. Now let's work on question 3. And we are going to start with question 3.1. Okay, so now we are going to work on question 3. And the first question will be question 3.1. So we are told that in a mathematical literacy classroom, a teacher keeps colored pencils in 3 identical cylindrical containers. Okay, so these pencils remain in the containers until they are used or lost. And then below is an example of an image of the container with the colored pencils and the diagram of the cylindrical container. So we have example of image of container with colored pencils, and then we have a diagram of cylindrical container with dimensions. So we can see that these containers have 2 dimensions. They have the diameter and the height as well. Okay, so now let's go ahead and answer question 3.1.1. So question 3.1.1 says that the diameter of one of the colored pencils is 6 milliliter. Okay, and the length is 16.7 centimeter. So verify with the necessary calculations that 39 colored pencils can fit into 3 of the cylindrical container. So first, what we need to do is to find the number of colored pencils across the entire cylindrical container. So now we need to find the number of colored pencils across the entire cylindrical container. So if we look at the diameter, we can see that the diameter of the diagram of the cylindrical container with dimensions, we are given the diameter of 83 milliliters. So first we need to find the number of colored pencils across. Number of colored pencil across the container. So we'll take the 83, which is our diameter, and divide by 6 milliliter. So remember that the diameter of one of the colored pencil is 6 milliliter. So if we want to find the number of pencils inside the cylindrical container, we take our diameter of all the pencils. So this is the diameter of all the pencils that can fit inside the cylindrical container, and then we divide by the diameter of one colored pencil, which is 6. And then now we can be able to find the number of pencils that can fit in one cylindrical container. So we'll come and say 83 divided by 6, and our answer will be 13.83. Will be 13.83. And guys, a pencil needs to be a whole number, so it needs to be discrete, meaning that we will take away our decimals, and our final answer will be 13 pencils, because a pencil needs to be a whole number. So we can't have 5.5 pencils. It's either we have 5 pencils or 6 pencils or 10 pencils, but we can't have 10.10 pencils or 13.1 pencils. Okay, so our answer will be 13 pencils. So next, we need to calculate the number of colored pencils stacked vertically, which is down the height. Okay. And next, we need to find the number of colored pencils stacked vertically. So if this is our cylindrical container, so we need to find the number of stacked pencils. You see? So that's what that means. So we need to find the number of colored pencils stacked vertically down the height. So if it's a cylindrical container, so we need to find the number of pencils stacked vertically. If we can have two pencils stacked and then one on top of another, or if it is just one that goes all the way. So we need to find the number of colored pencils stacked vertically. Down the height. Okay, so we'll come and say, so we know that our height is, we know that our height is 22 centimeters, and we are told that and the length is 16.7. So we are going to divide by 16.7. So if we come and say 22 divided by 16.7, we will have 1.317. So this means that only one person can fit from down to top. So there won't be any pencil that is on top of another pencil. That's why our answer is 1.317. So that's what that means. So now we need to find the number of pencils inside the container. We need to calculate the number of pencils inside the container. So we know that we have 13 pencils. So we are going to say 13 divided by 1, because each pencil will only stand. There won't be a pencil standing on top of another person. So we know that we will have 13 pencils per container. 13 pencils per container. Per container. And if we have 3 containers, it means that each container will have 13 pencils. So we'll just say 13 multiplied by 3 containers. Meaning that in total we will have 13 multiplied by 3. In total we will have 39 pencils. In total we will have 39 pencils, and that is our answer, because remember that the question said that verify with the necessary calculations that 39 colored pencils can fit into 3. So this is the 3 that they are talking about. Into 3 of the cylindrical containers. So yeah, we can verify that 39 pencils can fit. Okay, so now let's move to our next question, which is question 3.1.2. So I know that This can be a bit confusing, but you can always rewind, guys, so that you can understand, so that you don't miss anything, okay, before moving to the next question. So you can pause the video and rewatch that part again so that you fully understand before moving to the next question. Okay, so now let's move to question 3.1.2. So question 3.1.2 says that the teacher packs some of the colored pencils as follows in each of the containers. In each of the containers, meaning that this is packed on those 3 containers. Okay, so we know that we have 3 cylindrical containers. So maybe we can just show them just a bit. Yeah, excuse my drawings, guys. So we have 3 cylindrical containers. So we are told that the teacher packs some of the colored pencils as follows in each of the containers: 3 pink, 2 black, 2 purple, and 3 orange pencils. So we have 3 pink and 2 black, 2 black, and 2 purple, and 3 orange. So they packed like this in all 3. So even here we still have the same. We have 3 pink, 3 pink, we have 2 black, we have 2 purple, and we have 3 orange. So that's what that statement is saying. So even here, same thing. We have 3 pink, we have 2 black, we have 2 purple, and then we have 3 orange. Okay, so that's what that statement is saying. So we are told to calculate the probability that if a colored pencil is taken from all the 3 containers, or is taken from all the containers, it will be a purple pencil. Give your answer to 3 decimal places. So we need to calculate the probability that if a colored pencil is taken from all the containers, it will be a purple pencil. So we know that in total we have 39 pencils from all these 3. So we have 13 here, 13 here, and 13 here. So we have 13 colored pencils in total. So the probability that a purple pencils can be chosen will be, so we have 2 purple here, 2 purple here, and 2 purple here, meaning that we are going to say 2 plus 2 plus 2, because each container has 2 purple pencils. So meaning that our probability will be 6 divided by 39. And remember that we are told to answer it in 3 decimal places. So our answer will be 6 divided by 39. It will be 0.154. So our final answer will be 0.154. Okay, so we have rounded up the 4. It was 3, but now it's 4 because we had an 8. Okay, so now let's move to our next set of question, which is question 3.2. which is question 3.2. Okay, so maybe we can just create a bit of space before we move. Remember, we have extra classes, guys. So our extra classes are 80 rands per month. And if you want to join, you can just WhatsApp the number you are seeing on the screen. So now we'll be moving to question 3.2. So we are told that invitation cards for a party are in a rectangular shape with a circular photo of the birthday girl in the middle of the invitation card. An example of the invitation card is given below and a diagram with dimensions. So in this case, we are going to start with question 3.2.1, and the first question is A. So we are told to calculate the area of the rectangular invitation card to the nearest mm squared, milliliter squared. Okay, so our area will be, so we are even given the formula. Our area will be length multiplied by width. So if we check our length, we can see that it is given in centimeters. So we need to convert it to millimeters. So converting from centimeter to milliliters, we multiply by 10. We multiply by 10. So we need to convert it first. So converting from millimeter to, not millimeter, converting from centimeter to millimeter, we multiply by 10. So we need that 15. We need that our length, which is equals to 15, will now be, remember we're multiplying by 10, will now be 150 millimeters. So just to verify that, we are coming and say 15 multiplied by 10 is equals to 150. Okay, so now let's calculate our area. So our area will be equals to our length, which is 150, multiplied by our width, which is 120. And our area will then be 150 multiplied by 120. So our area will be 18,000 millimeter squared. Okay, so now let's move to our next question, which is question B. So question B says that, hence calculate the area of the rectangular invitation card without the photo to the nearest millimeter squared. So we need to calculate the area of the rectangular, but without the photo. Remember, this is our card, guys. Remember this is our card. So it has a photo inside. So we need to remove. That's what the question is saying. We need to remove this. Okay. So First, we need to calculate the area of the circle, and the formula is given: area of the circle equals to pi multiplied by our radius to the power 2. Pi is given and it is 3.142, and our radius will be 40 to the power 2. So you might be asking yourself, where is the 40 coming from? Okay, so if you look at the photo in between, you can see that we are given its diameter. So its diameter is given, and its diameter is 40. So to get the radius, you divide the diameter by 2. So radius is equals to diameter divided by 2. That's why we have 40 here, meaning that we will have 80 divided by 2, which then results in 40. Okay, so that's where the 40 is coming from. So we are calculating the area of the circle, and then after getting the answer, we will need to subtract it from our area of our rectangle, because this is what we need to remove. So we are trying to remove this. So we remove it by calculating the area of the circle first. And if we plug this on our calculator, let's go ahead and do it. So we'll say 3.142 multiplied by 40 to the power 2. And the answer will be 5027. So now we have calculated the area of our circle, and we are asked to remove it from the area of our rectangle. And we have already calculated the area of our rectangle, which was 18,000. So now we need to calculate the area without a photo. So we'll come and say 18,000 minus 5027.2, and that will be our final answer. So we'll come and say 18,000 minus 5027.2, and our answer will be 12,972.8. Okay, and that's our final answer. Okay guys, so now let's move to question 3.2.2. So before we move, we need to create a bit of space first. Before we do that, we need to create a bit of space. And don't forget to subscribe, guys. Don't forget to subscribe to the channel so that when we upload our next videos, you can be able to see when you get on YouTube without having to search for our channel. Okay, now let's move to question 3.2.2. 3.2.2. So question 3.2.2 says that one of the guests buys a gift that is packed in a rectangular box as shown below. And she must wrap the gift box with wrapping paper. So the box has 3 dimensions. So it has the length, the width, and the height, and they're all given in centimeters. Okay, so We are asked to calculate the surface area in centimeters squared of the paper that is needed to wrap the gift box. And we are given the total surface area formula. So we are given the total surface area formula. Okay. So the formula says that it's 2 in bracket length multiplied by width. So let the length is 38.8, then multiply by the width, which is 27.5, and then we add 2 again, width multiplied by the height. Our width is 27.5, so everything is given. We are just copying. We are just copying from the information that is given. So it's 27.5 multiplied by our height, which is 30. Okay, and then plus 2 in brackets our length, which is 38.8 multiplied by our height, which is 30. So yeah, and then we just plug everything inside our calculator and then we get our answer. As simple as that. So we come and say 2 in brackets 38.8 multiplied by 27.5, close brackets, and add 2 open brackets 27.5 multiplied by 30 plus 2 open brackets 38.8 multiplied by 30 close bracket, and our answer is 6112 centimeter squared. So we're told to give our answer in centimeters squared, and then that's our final answer, and we are done. And we'll be moving to question 3.3. 3.3. Okay, so we'll be moving to question 3.3. So we are told that electricity has become a scarce resource in South Africa. As a result, the country is investigating alternative sources of generating electricity. One alternative source is generating electricity. One alternative source of generating electricity is a wind turbine using rotating blades as shown in the picture and diagram below. Okay, so we are told that the wind turbine is mounted on the top of 50-meter high tower, and the length of each blade is 31 meter. Okay, so now let's go ahead and answer our question. So we'll start with question 3.3.1. Okay, so question 3.3.1 says that determine the length of the diameter of the circle that the blades create as they rotate. So we are told to determine the length of the diameter of the circle that the blades create as they rotate. So now we need to look at our so we need to determine the length of our diameter. And if we look at our circle, so this is how we should approach it. So from the center to the edge, we have 31 meters. So this is our radius. Guys, this is our radius. So remember that our radius is any point from the center to the edge, and then our diameter is any point from the edge to another edge to another edge. meaning that if we have our radius and we need to determine our diameter, we just multiply our radius by 2, and that will be our diameter. So our diameter will be equals to 31 multiplied by 2, and 31 multiplied by 2 should give us 62 meters. And then that's our answer for question 3.1. And now let's move to question 3.3.2. 3.3.2. So question 3.3.2 says that calculate the maximum height from the ground to the tip of the blade if the turbine is rotating. Okay, so if we look at, so this is what we are going to do. So from the ground, so this will be our ground. Okay, so if we look at our on the picture that we are given, we can see that from the ground to the center, this is equals to 50 meters, and we know that from the center to the top is equals to 31, meaning that if we want to calculate the maximum height, we just add the 2. We just add the 2. So our answer will be 50 plus 31. And if we add the 2, our answer will be 81 meters. And then we are done. Straight to the point. Okay? So now let's move to question 3.3.4. 3.3.3. Okay? But before we do that, let's just try and see if we can just create a bit of space. Okay? Let's create a bit of space. And if you have comments, guys, you can just leave them on the comment section below, and then I will check them and try and assist as much as I can. And if you want to join our extra classes, you can just send a message on WhatsApp to the number that you are seeing on the screen. So now let's move to question 3.3.3. Question 3.3.3 says that calculate the circumference of the circle made by the blades when it rotates twice. When it rotates twice. Okay. So now we need to calculate the circumference. Circumference. And it's 2 pi r. This is our formula and it was given. Remember that the question says that calculate the circumference of the circle made by the blade when it rotates twice. So now we'll come and say 2 multiplied by pi, which is 3.142, and then our radius, which is 31. And then we can just plug this into our calculator. So we'll say 2 multiplied by 3.142 multiplied by 31, and our answer will be 194.804. But remember that the question says that calculate the circumference of the circle made by the blades when it rotates twice. So here it's rotating once. So when it's rotating twice, we just multiply by 2 because it's rotating twice. Okay, and our final answer will then be, so it's 194.804 multiplied by 2, and our final answer will be 389.608. That's our answer. Okay. So now let's move to our next question, which is question 3.3.4. So question 3.3.4 says that suppose each household requires 25 kilowatts of electricity daily. Okay, if one wind turbine produces 1,750 kilowatts of electricity daily, calculate how many households could be provided with electricity daily from one such turbine. So if it is producing 1,750 and one household only need 25, it means that we divide by 25 to find the number of households that would be provided with. Okay, so we'll come and say 1750 divided by 25, and our answer will be 70 households. And then now we are done with question 3.3, and we will be moving to question 3.3.4. Maybe before we move to question 3.4, we can just create a bit of space again. We can just create a bit of space. .4. So we are told that Sandra washes her dishes by hand 3 times daily in 2 identical cylindrical basins. So we are told that she washes her dishes 3 times in a day, and she washes them in 2 cylindrical basins. 2 cylindrical basins. So maybe we can just show that here as well. Okay, so she washes them 3 times in these 2 cylindrical basins, and then she uses 1 basin for washing the dishes and the other for rinsing the dishes. Each basin has a radius of 30 centimeter and a depth of 45 centimeter, as shown in the diagram below. So it has 2 dimensions. It has the radius and the height, and the radius is 30 centimeter and the height is 45 centimeter. Okay, so we are told that Sandra fills each basin to 3/4, so it's 3/4 of its capacity whenever she washes or rinses the dishes. So 3/4 means that it's not full, but it's nearly full. Okay, and then we are told to calculate how much water in liters she will use daily to wash and rinse dishes by hand, and then note that 1000 centimeter is equals to 1 liter, and then we are told to use the following formula. Okay, so we are told to use the volume formula. So we will come and say our volume is equals to pi multiplied by our radius squared multiplied by our height. So our pi is 3.142, and then our radius was given as 30 centimeters. So our radius was given. So if you look at the diagram, you can see that our radius is from the center to the edge, and it was given as 30. So that's our radius. So it's 30 to the power 2 multiplied by our height, which is 45. And remember, guys, she is using 2 basins, meaning that we need to multiply by 2, and she washes the dishes 3 times a day, meaning that we need to also multiply by 3, and then now we can calculate our answer. So our volume will be, so it's 3.142 multiplied by 30 to the power 2 multiplied by 45, multiplied by 2, multiplied by 3. And our answer is 76,763,506 centimeter cube. So this is our volume. And then now we need to calculate the liters of water used daily. So we need to calculate the liters of water used daily. Liters of water used daily. So what we need to come and do first, we need to come and say we take our volume of 763,506 and multiply by the liters of water used daily. So we know that she doesn't wash when the basin is completely full. So she washes when it is nearly full, when it is 3/4. So this is the volume when the basin is completely full, but she doesn't wash her dishes when it is completely full. She washes when it is 3/4, nearly full. Okay, so now we will get our volume, the liter of water used. So we'll come and say 763,506 multiplied by 3/4, and our answer will be 572,629.5. Okay, and then centimeter cube. So if we go back to our note, we can see that 1000 centimeter is equals to 1 liter. So to find the number of liters, we will come and divide our volume by 1000. So we'll come and say 572,629.5 divided by 1000 to find the number of liters, because we are told that 1 liter is equals to 1000 centimeters. Okay, so we'll come and divide this by 1000, and our liters will be 572.6294 liters. And then that brings us to the end of question, 3. Now let's work on question 4. Question 4. Okay, so we are going to start with question 4.1. So we are told that Mr. and Mrs. Turner went shopping in Phuket, Thailand on Friday and checked into a hotel afterwards at 3:30 in the afternoon, and they departed from the hotel the following Tuesday at 10 in the morning. They bought a small cylindrical gift box for their daughter to keep her earrings and hair accessories in, as shown below. And the box has the cylindrical box has 2 dimensions, the diameter and the height. And we are also told that the area of a circle is equals to 3.142 multiplied by the radius to the power 2, and the volume of a cylinder is equals to 3.142 multiplied by radius to the power 2 multiplied by height. Okay, so now let's go ahead and work on the questions. So question 4.1.1 says that verify with the necessary calculations that the total number of hours that Mr. and Mrs. Turner stayed in the hotel was less than 90 hours. Okay, so what we know is that they arrived on Friday and they stayed Saturday to Monday, full days, and then they left on Tuesday. So on Friday they stayed from, remember they arrived at 3:30, meaning that they arrived at 3:30, and then we can count the hours till midnight. Till midnight, which is 12. Is it 12 a.m.? Yes, 12 a.m. Okay, and then Saturday to Monday they stayed for 24. They stayed for 24 hours, which is full days, a full day. Ne? So they stayed Saturday, Sunday, and Monday. So the 24 will be multiplied by 3 because it's 3 days. And then on Tuesday, we can count from 12 a.m. to 3, not to 3, to 10 a.m. in the morning when they left. So we can see that on Friday they stayed. So if we count from 3:30 to 12 midnight, hours will be 8.5 hours. And then if we count 24 hours multiplied by 3, this should give us roughly 72, because it's 3 nights. So it's 24 multiplied by 3. The answer will be 72 hours. And then on Tuesday they only stayed 10 hours. So from 12 midnight to 10 a.m. is 10 hours in total. So the total hours will be, total hours stayed in the hotel will be 8.5 plus 72 plus 10. So it's 8.5 plus 72 plus 10. So it will be 90.5 hours. And this is more than 90 hours. The question says that verify with the necessary calculations that the total number of hours that Mr. and Mrs. Turner stayed in the hotel was less than 90 hours. So the statement is invalid because it is more than 90 hours. Okay, so now let's move to the next question, which is question 4.1.2. So question 4.1.2 says that the volume of their daughter's cylindrical gift box is 1,571 centimeter cube with a diameter of 10 centimeter. Calculate the height of the cylindrical gift box. So we are given the volume and the radius. So the only thing that's missing here, it's the height. So the volume is given. So if we check on our diagram, we can see that we are given the volume formula. So it's volume equals to our pi, which is 3.142 multiplied by our radius to the power 2 multiplied by our height. So the volume is given and the radius is given, but the height is not given. So that's what we are looking for. So the volume is 1571 equals to 3.142. Our radius, so our radius will be 5, because remember that, so we're not given the radius, we are given the diameter, but if we have the diameter we can be able to get our radius. So radius is equals to diameter divided by 2. Our diameter was 10 divided by 2, meaning that our radius will be equals to 5. So that's our radius, guys. And then our radius will be 5 to the power 2 multiplied by our height, the one that we are looking for. Okay, So now we can just erase this because we have explained it, and I'm more than positive now that you understand what a radius is. Okay, so now we will just go ahead and say 1571 equals 2. So we can just multiply the 2. So if we say 3.142 multiplied by 5 to the power 2, we will have 78.55 multiplied by our height. So now if we want to get our height, we need to take this to the other side. So we know that we can take it to the other side, but in this case we have a multiplication sign in between. But if it was an addition, or a subtraction, we're going to just take this to the other side. So in this case, because we have a multiplication sign, it means that we just divide. It means that we divide. So if we divide this side by 78.55, the 78 and the 78 will cancel. And one important thing is that what you do on your right hand side, you always need to do it on your left hand side. So because here we divided by 78.55, it means that even on our left hand side, we still need to divide by 78.55. And now on the right hand side, we'll be left with our height. And then now we will just divide the two to get our height. So we'll say 1571 divided by 78.55, and our height will be 20 centimeter. And then there we go. Okay, so now let's move to our next question, which is question 4.1.3. So we can just start by making space for that. Don't forget to subscribe, guys, so that when we upload, you can be able to see our videos quicker. Okay, so now let's move to question 4.1.3. 4.1.3. So question 4.1.3 says that the top and the bottom of the cylindrical gift is made of a special type of wood that costs 144.65 rand meter square. Calculate the total cost of the wood to make the top and the bottom of the cylindrical gift. If the area of the top is 78.55, so we are given the area of the top. Okay, so we are given the area of the top, and we need to calculate both the top and the bottom, meaning that to have both the top and the bottom, we just calculate the top by 2, because we need both the top and the bottom. So we'll say we'll say 78.55 centimeters squared multiplied by 2, because this is for the top. So if we want to also include the bottom, we need to multiply by 2 to include the bottom. So if we calculate this, we should, so let's see how much we'll get. So we'll say 78.55 multiplied by 2, and our answer will be 157.1 centimeter squared. So remember, we need to calculate the total cost of the wood. Okay, so our answer is in centimeter squared and our price is in meter squared, meaning that we need to convert from centimeter to meter. We need to convert. So converting from centimeter to meter, we divide by 100, meaning that we are going to say 157.1 divided by 100. So it will be 157.1 divided by 100, and our answer will be 1.57 1.571. Yeah, I think that should be our answer. And now to get the total cost. To get the total cost, we need to come and say, wait. Let's see what we need to do. So it's 157. So I think we made a mistake here. Let's double check this. So it's 157.1 divided by 100. So it's 100 to the power 2. So it's 100 to the power 2. So we divide by 100 to the power 2. So let's make it a bit clearer. So we divide by 100 to the power 2 because we have the top and the bottom. Is that the case? No, because we have centimeter cube. That's why we also need to have 100 to the power 2. Yes, so our answer will be 0.01571. And then after getting that, we can find our total cost. So our total cost will be equals to 0.01571 multiplied by the cost of wood, which is 144.65. So our total cost should be so it will be 0.01571 multiplied by 144.65. So it should be 2. Our total cost should be 2.27, and that's our final answer. Okay, so now let's move to the next set of questions, which are question 4.2. And if you do have any comments, guys, you can just leave them on the comment box and I will attend to them. And we do have extra classes, guys, which costs only 80 rands per month. So you can join and be able to learn with other kids. Okay, so now let's move to question 4.2. So question 4.2 says that Miss Haker asked a builder to draw a scale drawing of a proposed renovation to her house. The floor plan of the proposed renovation is shown below. So it is shown below. So now we are okay. So now we have a set of questions that we need to answer. So we are going to start with question 4.2.1. So question 4.2.1 says that the measured length of the main bedroom is 3.4 centimeter. Use the given scale to calculate the actual length of the main bedroom. So by actual, they mean in real life. By actual, they mean in real life. So we know that 1 centimeter on paper is equals to 65 centimeter in real life. Okay, so to answer this question, so this is given on the scale. So if you look at the scale on the right hand side, you will see that 1 is to 65. So it means that 1 centimeter on paper is equals to 65 centimeter in real life. So to calculate the length in real life, it means that we just multiply by, to calculate the actual length, we will come and say 3.4 centimeter multiplied by 65, and then our answer will be so it's 1, not 1, so it's 3.4 multiplied by 65, and our answer should be 221 centimeters. So what does this mean? What does this mean? This means that 3.4 centimeter on paper is equals to 221 centimeters in real life. In real life. Okay, so now let's move to the next question, which is question 4.2.2. So question 4.2.2 says that what is the probability of selecting a door that opens to the eastern side? Probability. What is the probability? So if we look at our picture, is it a picture? If you look at our plan, we can see that we have something that says, we have an arrow which says this is north. Okay, meaning that our diagram will now be in opposite direction. So we'll have north, south, east, west. Okay, so that's what we need to take into consideration. Okay, so our probability, now we need to calculate our probability. So the question says that what is the probability of selecting a door that opens to the eastern side? So first we know that we need to divide by the total number of doors. Total number of doors. So in this case, the doors that opens to the eastern side would be represented like this. It will be shown like this on the map. So we need to count these doors and then come and write here eastern doors. Okay, so if we count them, we can see that we have 1, 2, 3. So there are only 3 doors that are like this, that opens to the eastern side, to this side. Okay, so we will have 3 divided by our total number of doors. So if we count the total number of doors, we can see that they are 1, 2, 3, 4, 5, 6, 7. So our answer will be, our probability will be 3 over 7. So now let's move to the next question, which is question 4.2.3. So question 4.2.3 says that given that the house is situated in South Africa, explain which home will get most of the sun. So we know that in the southern hemisphere, the sun moves from east to west, meaning that it moves from east to west and it moves through the northern direction. So it means that it moves into this direction. You see? Meaning that the room that is facing north will get most of the sun. And we can see that on our map or on our plan, the main bedroom is the one that is facing north, meaning that the room facing north will be the one that will get most of the sun. So it will be the main bedroom. The answer will be the main bedroom. So that brings us to the end of this question. And don't forget to like, share, and subscribe, guys. And if you want to join our extra classes, you can just text the number on the screen. Okay, and we do have study guides for maths literacy. We do have study guides as well. So if you need a study guide as well, you can just send us a message on WhatsApp and we'll be able to assist you with that. Okay.